Hey guys, and welcome back. Today, I would like to provide you with 3 quick tips on how you can better optimize and control your costs for serverless SQL pools. Before we get to the actual tips, let's talk about how costs work when utilizing serverless SQL pools. Serverless SQL pools are built based on the amount of data that you process. So this could be the data that you are actually reading in from your data lake. This could be the intermediate results as your data moves in between compute nodes, or this could be the actual data that you are writing back out to your data lake. The data that you process will be billed at $5 per terabyte. The first terabyte is actually free until June 30th, 2023. Every single T-SQL statement that you run will incur a minimum charge of 10 megabytes. Every single request will be rounded up to the nearest megabyte. All right, so now let's get to those tips. Tip number 1, ensure that you are working with efficient file types. For serverless SQL pools, the recommended file type is the Parquet file type. The Parquet file type just has an enormous amount of advantages compared to other types such as JSON files or CSV files. Parquet files will store your data in a columnar format. CSV files will actually store your data in a row-oriented format. The benefit of the columnar format is that it is going to allow the optimizer to easily only read in the columns that you need for your specific request. So if you have one data set with 100 columns, if you were to utilize the Parquet file type, and let's say that you only needed to read back 10 columns, the optimizer can now go out and only read in the 10 columns that you actually need. For CSV files, since they are in a row-oriented manner, the optimizer will actually need to read all 100 columns just to get back the 10 columns that you actually need for your request. By being able to only read in the 10 columns that you actually need, this is going to improve your workload performance and reduce your actual cost. The second great thing when working with Parquet files is that they natively utilize a compression engine. The compression engine can help to compress your data sets in many use cases to nearly 1/5 the size of a comparable CSV file. Reducing the size of your data sets will help you to reduce the data sizes that you are reading in from your data lake and the data sizes that you are having to write back out to the data lake, thus resulting in improved performance and lower cost. Let's go take a quick look at some of these concepts in action. All right, guys, so we are logged into the Synapse Studio tool here, and I want to briefly show you all the beauty of working with Parquet files and why they are so advantageous compared to working with other file types here. I have a notebook here that I'll be working with today, and the beautiful thing about notebooks is that it allows you to maintain your output from the code that you execute in each of the cells inside of the notebook. For the sake of time today, I have already executed the code in my notebook here, but we will walk through each of the cells here just to make sure that we understand what we're doing here. The first cell here, what I'll be doing is I'm going to import some New York City taxi data from the Azure ML open data sets here. Once that data is actually imported, I'm going to parse that data down so that I only maintain the data from the year 2018. And then I'm going to load that data into a data frame. Once that data is loaded into the data frame, I then want to display the first 5 rows just to make sure that everything here looks good. And as we can see, our data is all here and everything is good for our data frame here. Our next cell here, what I'm doing here is building out a path here to my data lake storage account here. And then in the next cell here, I am just appending on output names to my data lake paths here. And then in my last frame right here, what I'm doing is taking my New York City taxi data frame that was trimmed down to only the year 2018, and then I'm going to write that data back out to my data lake in both the Parquet format here and in the CSV format. and those steps have already completed. So what I want to do now is I am going to jump over to Azure Storage Explorer really quick. All right, so we are logged into Storage Explorer now, and as you can see, we have my two folders right here with my New York City taxi data in it. So what I want to do first is open up the folder right here containing the CSV files for my New York City data. And then I'm just going to click on the More tab right here and then click on the folder Statistics. And as you can see, my CSV folder here contains 28 blob files that total out to 10.85 gigabytes. So let me just come back real quick, and then I will open up my Parquet folder. And once again, I will click on the More button and then click on the folder Statistics. And now we can see that we have the same 28 blob files here, but the total data size is only 2.27 gigabytes here. So already just looking at this, we can see that the Parquet file is roughly 1/4 the size of the CSV files. So we can already see how the built-in compression that you get by utilizing Parquet files is able to reduce your data sizes to nearly 25% compared to CSV files. Reducing the size of your data sets will not only lead to better workload performance, but it's going to lead you to lower cost, because this is just going to be less data that you have to read in, less data that has to move in between your compute nodes, and less data that you then have to write back out to your data lake. So less data equals less cost. Tip number 2, ensure that you are utilizing partitioning for your Parquet files that are stored inside of your data lake. Partitioning your data will help the optimizer to take advantage of what's called partition elimination. Partition elimination is the process when the optimizer can only read in the partitions that you need as part of your T-SQL request, and then it can ignore the other partitions. So let's just say that you work for a retail company and your company has 10 years worth of retail data. For your particular project, you have been tasked to report on sales numbers from the past 1 year only. If your data is partitioned based on the actual year, the optimizer can go out and only read in the partitions for that 1 year to meet your actual workload needs, and then it can ignore the partitions from the other 9 years. Being able to ignore the partitions that you don't need will help you, once again, to improve your workload performance, and is going to help you to reduce your costs. So once again, let's go take a look at this in action. All right, guys, so we are logged back into the Studio tool here now, and we are back inside of our notebook here. And from the next cell right here, the next thing that we're going to do is we're going to take our data frame that we have, which contains the New York City taxi data from the 2018 year, and we're going to write this data once again back out to the data lake. But this time we are going to partition that data based on the year and the month. So this cell has already been executed. So I will jump back over to my Storage Explorer tool really quick. All right, so we are back into Storage Explorer tool. And as you can see, we have our New York City taxi Parquet file, and now we have a new folder here for New York City taxi partition. So if we look at just the regular Parquet file here, you can see that all of our data is stored inside of this one folder right here. And if we jump back and look at our partition folder here, we can see that our data is now partitioned out based on the year first, which is 2018 only, and then by the actual month. So inside of each one of these, we have the data just for that one particular month. So what I'm going to do now is I'm going to jump back over to my Studio tool once again. And I have some SQL scripts here that we're going to execute. So the first script here is just going to pull back our year, our month, the passenger count, and the trip distance. But we are only interested in the 2018 data from the month of January right here. Now, this statement here is still running and this may take some time, but we can jump over here to our messages tab and we get some pretty cool information here. So the optimizer already knows exactly what it needs to do to retrieve the data that you requested from your T-SQL statement. So if we look down here, we can see that the total size of the data scanned is 921 megabytes. The total size of the data that moved between the compute nodes was 123 megabytes. And then there was no data that was actually being written back out to the data lake. Now, keep in mind, this statement here is not going to pull back all of the January 2018 data, because if we look over here in the properties blade, it is defaulted to only pull back the first 5,000 rows here. So for the first 5,000 rows, we are scanning 921 megabytes and moving 123 megabytes. So I will jump over here real quick to another window here, and we're going to look at this statement here. So we're pulling back the same data here, but the beautiful thing that we can do now is we can take advantage of these function calls here, which is called the file path function here. And basically what these functions do is when we specify our data lake location, we can pass in wildcards here that represent specific things that our data is partitioned by. So in our particular use case, we partitioned our data based on the PU year and the PU month. So we passed in a wildcard for the year, the month, and the file name right here. But then in our where clause, we're going to say where file path number 1, which corresponds to that very first wildcard right here. So basically that represents the year. So we're saying the first wildcard should be set to 2018, and then the second wildcard right here, which is for the PU month, it should be set to the first month. So once again, we're going to look at our results here. And already we can see a major difference here. So the optimizer now knew exactly where it needed to go to find the data for January 2018. So all we had to do was scan 80 megabytes worth of data. And then we still had to move the same 123 megabytes over. But this is a huge drop off compared to the 921 megabytes that we had to scan when the data was not partitioned out. So looking at this, we can easily see how partitioning your data can lead to lower data that needs to be scanned, potentially lower data that may need to be moved, and lower data that may need to be written back out to the data lake. So partitioning is a great way to really help you to optimize your workloads and reduce your total cost. Tip number 3. Take advantage of the cost control feature that is built into the serverless SQL pools. The cost control feature will help you to set a daily, weekly, and/or monthly limit to the data that your serverless SQL pools can process. By setting these limits is going to help you to ensure that you can remain within your budgets. Once your SQL pools have reached their actual limit, you will get an error message that lets you know that you have reached that actual limit and you can no longer process new data requests. All right, so let's go take a look at this last tip here. All right, guys, so we are logged back into the Studio tool, and the last thing that I would like to show you guys is the cost control feature. So what we are going to do here is come down here to our Manage Hub, and then we are going to click on our SQL pools, And then we are going to come down here to our built-in pool. And then we are going to click on this little icon right here, which is going to be our cost control feature. Once this pulls up here, we can see that it gives us an option here for us to set a daily limit, a weekly limit, and a monthly limit for the data that we are going to process. So in this particular use case, let's just say we wanted to set a daily limit of 50 terabytes here. And then we could also set a weekly limit of, let's say, 200 terabytes. And then let's just say we want to set a monthly limit of 500 terabytes right here. We could set these limits, apply these, and then once we reach either our daily limit, our weekly limit, and or our monthly limit, we will receive a error message, and then we will no longer be allowed to process any more data here. So once again, this is just a great way to ensure that you remain within your budget. All right, guys, so those are 3 quick tips to help you to better control and optimize your costs with serverless SQL pools. So let me know in the comments section which one of these tips you guys plan to implement next for your workloads. And last but not least, don't forget to hit that like button and subscribe to my channel. Until next time, guys, peace.